How to find a p-value. Okay, here is a couple of hypotheses. We have one that p is equal to 0.6, one that p is greater than 0.6, and we go out and take a poll, we find some evidence, and we end up getting n equal to 50, and let's say that x is equal to 33. So we get 33 yeses and 50 tries. It turns out that p hat, in this case, is equal to 0.66. So 0.66 does support this alternative hypothesis. We want to see if it supports it strongly enough. In order to do so, what we do is we just look at the z-score of this, assuming that this is the actual p. We assume that the null hypothesis is true, and then we check out its z-score. You might remember the standard error for p hat is given by this, square root of p times q all over n. So in this case, since we're assuming that's p, that's equal to the 0.6 times 0.4 divided by n, which is 50 in this case. 0.6 times 0.4 divided by n, I'll use my calculator, square root, I'll turn it on first, clear all that mess, square root of 0.6 times 0.4 divided by 50, and then I'm going to store that as alphabet S. Okay, so that's going to be stored as S, so there is the standard deviation for p hat. That basically means that if you took a whole bunch of p hats from a population that had sample size of, or a sample size, or p hats from sample sizes of 50 from a population that has a distribution that has 60% successes in that distribution, you get something that looks like this, and the standard deviation would be that number. Okay, looking good. So now all we're going to do is find our z-score. The z, if you might remember, is equal to the individual minus its expected value divided by its standard deviation. In this case, it's p hat minus p under the null hypothesis divided by the standard deviation. p hat minus p is equal to 0.67 minus 0.6. So 0.67 minus 0.6 is that. S is that. So let's look and see what our p hat is. If we take 0.07 and we divide it by our last S, we get 1.01. So 0.07. So it turns out that this is one standard deviation above the mean if n is equal to 50 and the mean is 0.6. We know that that's not close to 2 standard deviations away. Let's see what our actual p-value is. So we're going to look at the standard normal curve that has a mean of 0 and a standard deviation of 1. And we're going to look and see what the area to the right of 1.01 is. We're going to find our, we call that our test statistic, and we're going to look at that area to the right of that test statistic. Many of you guys know that the answer is going to be way bigger than 5%, but let's check it out anyway. We go second, distributions. We go down to the normal, CDF. 1.01 is our lower bound. Our upper bound is infinity. The mean is 0. The standard deviation is 1. Paste that in there and see what that works out to be. That works out to be 15.6%. So this area right here is 0.156. That's our p-value. This number here is called the test statistic. This area up here is called the p-value. That's it. Since this p-value is way higher than a threshold of alpha is equal to 0.05, we're going to fail to reject. There is not enough evidence that the p is greater than 0.6. Some evidence, but not enough to be able to reject the null hypothesis.